Hello everyone, this is Computer Science for class 12th online study material, and the topic for this video is functions in Python. To begin with, let's have an introduction. In mathematics, we can represent a function as z is equal to f of x comma y, where x and y are inputs and the function operates on them and the output is stored in z. Now the same can be related with the Python concept of a function. You're already familiar with the length function. If I write n is equal to length of my list, then the length of this list will be calculated and stored back into n. However, the programming functions are much more generalized and versatile than the mathematical definition of a function. So in a programming language like Python, a function is a self-contained block of code that is used to perform a single task or a related group of tasks. Functions promote modularity and reusability. A big problem like designing a car can be divided into multiple small problems, and we can write separate functions for those small problems. So moving on ahead, the need for functions can be better understood with the following example. Let's say we have to calculate BMI of students of a class, body mass index. So without functions, let's say what we do is we write 10 or 12 lines of code to print a descriptive information related to the BMI. Now, for 80 students, you have to repeat these 10 or 12 lines of code 80 times. And if any change is to be made, like if you have to add another category, then it will require editing at 80 places. On the other hand, if we use functions, then you can write this whole code inside a function definition. Then whenever you need the functionality, you just have to write this one line to call the function. So for 80 students, instead of writing 10 or 12 lines each, you have to just write one line. And if any change is to be made, then it will require editing only the body of the function in here, only at one place. There are numerous advantages of using functions. Some of them are code reusability. A function can be called any number of times. Then you have increased readability. With functions, your total number of lines of code are reduced. Easy development, as work can be divided among multiple divisions. Then easy handling, because you only handle a portion of a code at a time. Then testing is also easy because faults can be isolated to particular functions. Updates are easy. As we saw in the previous example, changes are required only in the function body. Then code sharing, you can design functions and then you can create a library which can be used by someone else also. You can share your code. Abstraction of functionality. Code is hidden, only interface is required to invoke. Then we have this don't repeat yourself concept of software development, which is very important. And it is the strongest motivation for using functions, because when we use a library functions or a built-in function, you need not know the details of the functionality, how the implementation is done. It's like to drive a car, you need not know about the details of how the gearbox works, what is the type of the engine, how the engine works, how the axle works. You only need the interface, how to steer, how to put brakes or accelerator, how to stop. Okay, so for calling a function also, all you need to know is what arguments the function takes and what values it returns. That's it. So this is called abstraction of functionality. Now, types of functions in Python. First, we have built-in functions. Built-in functions are the ones which are already defined within the language and are ready to be used by the programmer. We have already used functions like print, int, range. Now, these functions are already defined, already there. We just need to call the functions to use. The second category is user-defined functions, the functions which are created by the user as per his or her requirements. Then we have library functions. These are the functions which are written into modules, and the library module can be imported whenever we need the functionality. Okay, it's just like a collection of functions written in a file. Okay, to use these functions, we can import that file. Then fourth is anonymous functions, also called Lambda functions, because they are not declared with the def keyword, which is used to define functions. More about them later. Moving on to the function syntax. The syntax of function is we have def keyword, which marks the beginning of the function, header. Then we have name of the function and then some optional parameters. This line is called the function header. Then we have docstring, a bunch of statements and an optional return statement. This makes the body of the function. And then we call the function outside by just writing the name of the function and we pass the parameters or the arguments. This is calling the function. Okay, this is definition of the function. Okay, so this is function call. Docstring is just a description of what your function does. You can use the built-in function help, then write the name of your function, and it will simply print whatever is written in the docstring. So moving on, let's understand what these individual components like def, name of the function, statements, return, what these are in detail. Okay, now def is a keyword which marks the start of the function header. With the def keyword, your Python compiler interpreter will know that this line begins the definition of the function. Okay, then we have the name of the function, which is just a valid Python identifier. You can use any name, but it is advised to use a descriptive name for your functions. Then we have parameters, optional comma separated list of parameters or the inputs that can be passed to the function. We have a colon, which is just a punctuation to denote the end of the header and start of the function body. Docstring, optional documentation to describe what the function does. Okay, but it is a very good programming habit to include docstrings in your functions. Okay, because you will not remember your own code. Okay, if you cannot remember what you had for dinner last night, then it is a very good practice to include documentation in your code. Okay, then statements, one or more valid Python statements that make up the function body, and statements must have the same indentation level. Then we have an optional return statement with which you can exit from a function or return a value. Okay, so let's have a test of your knowledge. Just pause the video and try to answer these questions. Moving on with the next topic, let's now have an example of a user-defined function. So we start with the keyword def whenever we have to define a function. Okay, so we'll begin with def, then name of the function. Here we are writing hello as the name of the function, and name is a parameter or input to the function. After that, we just write a line of the docstring, the description that this function just prints hello. In the body of the function, we just write one statement, print hello, along with the name, whatever the input was given to the function. Then outside, we can call the function by just writing the name of the function and passing an input. So the output of the function will be hello Sam. A function must be defined before it is called. You cannot call a function before its definition because Python is interpreted language. It goes line by line. So if it encounters a function call, then before that function must have been defined. Statements inside the functions must be intended at the same level. Then arguments are the values passed into the function and they correspond to the parameters in the function definition. More about arguments and parameters in later slides. You can define a function that doesn't take any arguments, but the brackets, the parentheses are still required, compulsory. Okay, now let's talk about the optional return statement. A return statement immediately terminates the function and the control is passed back to the caller. With return statement, we can pass the data back to the caller also. Now let's see an example in where there is a function called cube which takes one input parameter n. It calculates the cube of n and stores in result, then prints the result. On the other hand, we have a function with a return statement to return data back to the caller. Here the cube function calculates the cube of n, stores that in result, and then it returns the value of result. That return value can be assigned to a variable just by putting the function call on the right hand side of an assignment operation. Whatever is the return value will be now assigned to the variable on the left hand side C, and you can print C. Now with this first example, the result is printed in the function body itself and so cannot be used in expressions outside the function. But in the second example, the function returns the result. That value can be used in expressions outside return also. Your return statement can have multiple return values also and no return value also. Okay, let's see that in an example. Let's say we have to calculate a function to return a plus b, a minus b, a star b, and a divided by b for a and b. Let's define the function called CALC, calculate and pass A and B. Okay, we put up a condition that if B is equal to 0, because in that case division will not be possible. So we put up a condition that if B is equal to 0, print B can't be 0, and then we write return. We just write the return statement. No value is returned back. We just write return. It will simply exit from the function. In the else part, we return a plus b, a minus b, a star b, and a divided by b. 4 comma separated values, which is totally fine with Python. Now, to call this function, we can write a variable named t is equal to calculate 5 comma 6. So all these 4 values will be returned and stored in the tuple t. T will be a tuple having 4 values. Or you can unpack the tuple also. You can have 4 variables. Then automatically this a plus b will be assigned to sum, a minus b will be assigned to sub, a star to mul, and so on. Moving on ahead, let's talk about the flow of control for functions, how the control flows back and forth. Let's say we have a function called hello, and then in the main segment we call the function hello. So whenever function is called, the control jumps back to the body of the function, because functions are also like variable names. They have memory addresses. Okay, and whenever a function is called, the return statement, the address of this statement, third statement, will be stored in stack, that we have to come back to this statement later. And whenever the execution of the function is finished, or if you encounter a return statement, then the control jumps back to the point where it left off and resumes execution. The return address is fetched from the stack. Moving on ahead, we have the main function. Now in languages like C++ and Java, the main function is compulsory. It is a special function from where the execution of your code starts. In Python, we need not have a main function, but you can organize the code which is outside all other function definitions into a main function segment. And then the code outside will just be to call the main function. Here name is a special variable which gives you the name of the script. Okay, if it is the script is run directly, then the name is main. But if it is imported into another file, then it is the name of the module. Okay, so if we are importing our code into some other module, then we need not call main. But if we are directly running, then the condition will be true and the main will automatically be called. So time to test your knowledge. Just pause the video, go through these questions and try to answer them. Next topic is parameters and arguments. Let's define a simple function add, which adds two values a and b and returns the addition. And we call the function using 5, 7 as the input values. Now here a and b are called parameters. 5 and 7 are arguments. In the function definition, we have parameters, and in the function call, we have arguments. The parameters are also called formal parameters or formal arguments. Okay, and the arguments are also called actual arguments or actual parameters, because these are the actual values upon which we want to perform the operation. So moving on, there are various types of arguments in Python, mainly 4. First one is positional arguments, second one is keyword arguments, default arguments, and fourth one is variable length arguments. Let's first talk about positional arguments. Okay, now positional arguments, it is the most straightforward and simple way to pass the data to a function. Here we have a function definition. The name of the function is f. It requires 3 positional arguments: quantity, item, and price. These are called positional arguments because when we call the function, the order in which you pass the values will be matched with the parameters. 5 will be stored in quantity, apples will be stored in item, 90.5 will be stored in price. Okay, automatically the values are mapped. First argument will go into first parameter, second into second, and so on. Now there are some restrictions on positional arguments. First one is that order must match, because if you specify values in wrong order, then what happens is now this apple, the first argument will be stored in the first parameter quantity, 90.5 will be stored in item, and 5 will be stored in price. Okay, you may get output without any error, but that will not be the correct output. Okay, the other restrictions are the number of parameters and arguments must also match. Here we are specifying only two arguments. So Python will give you a type error that it is missing one required argument, the last one, price. And if you specify more than three, then it says Python, the function takes three arguments, but four were given. That is also a type error. Moving on to the next type of arguments, keyword arguments. Now when calling a function, you can pass the arguments in keyword is equal to value format. Each keyword must match with a parameter in the function definition. Let's have an example. The previous call can be written as this also. Okay, the values are 5, apples and 100. Okay, but we name them. So that is also fine. Now next is keywords must match parameters. So if you try to pass an argument which is not there in the function definition, the cost, that name cost is not there in the function definition. Okay, so then you'll get a type error that the argument cost is unexpected. Also, you can specify the keyword arguments in any order, unlike the positional arguments. So if I specify first item is equal to apples, then price, then quantity, so that is also fine because you're naming them. Python will know that, okay, quantity is equal to 5. So that is also okay. Okay, so order can be changed, but number still has to be same as the parameters. Okay, parameters are arguments must match in number. Then you can combine keyword arguments with positional arguments. Okay, for example, if you write, let's say f5 comma price is equal to 100, item is equal to apples. So automatically the first value will be assigned to quantity. Price and items are already mentioned here. So that is totally fine. Again, let's say first two values are passed using positional arguments, third one is keyword arguments. So that is also okay. Now care must be taken when you combine that positional keywords must come first. All positional keywords must come first. In here you have a keyword argument, then you have a positional one. Then in this case you'll have a syntax error that positional argument follows keyword argument. Moving on with the next type, default parameters. In the function definition itself, you can have a default value for the parameters. Okay, you can specify them in name is equal to value format, then the value becomes the default value for that parameter. These parameters are called default or optional because already they have been given a default value. You can skip them in the function call. Let's have an example. In here we specify default value for item and price, and we simply print the same line which was used in the previous example. Now to call a function, if you write f4, we give only one argument. So that is totally fine because item and price already have a default value, so that will be used. That is why these default parameters are also called optional parameters. Again, if you specify two parameters, then the third one's value will be taken by default. Here it says 15 bananas cost rupees 90.5. Moving on. Now order can also be changed if you put up a keyword argument. Okay, you write items is equal to bananas, then you give the positional argument value as a keyword argument. So if it is a keyword argument, the order can be changed also. Again, the care must be taken in the function header. When you define the function, the default parameters must not be followed by a positional parameter. Once you make one parameter as a default parameter, then all the other parameters on the right hand side of it must also have a default value. Otherwise, when you define your function, you'll get a syntax error that non-default argument follows default argument. Next topic is variable length argument. Sometimes you don't know in advance that how many variables, how many arguments will be passed to the function. For example, you want to calculate sum of arbitrary numbers. Now here, first approach is that you define a function sum with a, b, c and d have the default values. Now this function call can work for 2, 3 or 4 arguments. But what if you specify 5 arguments, 6 arguments, what happens? Okay, you can pass a tuple or a list. Okay, user can find the sum of the elements of a list or a tuple, but this functionality is automatically there in Python. You can pass the arguments, and in the parameter list, if you use a star operator, then automatically all the passed arguments will be stored as the elements of a tuple. For example, in here when we define the function, we define it as sum star t. Star t means it can have any number of arguments. All the arguments which are passed will be stored in this tuple. Then you can go through the values of the tuple, calculate the sum of all the values, return the result. Okay, now this function can be called with one argument also, two arguments also, three also, four also, seven also, eight also, any number of arguments. Okay. Let's have a summary of arguments and parameters. So we studied that positional arguments must agree in order as well as number with the parameters declared in the function definition. Keyword arguments must agree with declared parameters in number, but they can be specified in any order. And positional arguments cannot follow keyword arguments. Then we have default parameters, which are optional. And while defining, the non-default parameters must not follow the default parameters. One more thing, you cannot specify multiple values for an argument. For example, in here, we have a function, same function, quantity, item, and price are the parameters. To call the function, if you write 5, quantity is equal to 5. Now 5 is a positional argument, so it will automatically be assigned to quantity, the first parameter. And then again, you're specifying a keyword argument, quantity is equal to 5. So you'll get a type error that f function got multiple values for argument quantity. Moving on, let's have a test of your knowledge. Pause the video, try to answer these simple questions. The next topic is scope of variables. Scope of a variable is the portion of a program or the code where the variable is visible. Variables are created using assignment operations, function parameter definitions, and importing modules. Based on the location of the creation of variable, they fall into following scope categories. First one is local scope. The functions which are defined inside a function, inside the body of a function, or the parameters which are passed to the function are having local scope. They are not visible outside the function. Then we have enclosing scope. If you have nested function, a function inside a function, then the inner function can access the variables of the outer function, local variables of the outer function. That is called enclosing scope. Then you have global scope. All the variables which are defined outside any function definitions at the top level segment of your code are having global scope. Then you have built-in scope, which is the keywords, functions, or other attributes that are built into Python. Okay, let's have an example of local scope. Let's say the same program that we previously used to define to calculate the cube of a number. Okay, now we define this function result is equal to n into n into n. Now this result is a variable which is declared or defined inside the function cube. So this result is a local variable to the function cube. We can call the function cube and the result is printed. This one result will be printed inside the function. But if you try to print result outside the function definition in your main code segment, you get a name error that result is not defined, because this result is visible only inside the function cube. Outside it is not visible. And because local scope is different for different functions, variables can have same name in different functions. Different functions can use the variables of the same name. Here square is another function which uses again n, same result. Okay, now this result will be different from this result because both are visible only inside their respective functions. Let's talk about global scope. Here the function are the variables x and y. They are defined outside all the function definitions, so they are in global scope. We have a function definition. Here we define x is equal to 200. So x, a new variable is created which is local to my function. Now when you print the value of x, you access the x inside the function, the local copy will be accessed. And when you try to print the value of y, then global y will be accessed because there is no local y. And outside, if you try to access x and y, it will access the global values of x and y. Next is lifetime of variables. It is the time for which a variable is in existence. For global variables, it is as long as the script runs. For the local variables, it is the lifetime of the function. Once the function stops execution, the local variables are destroyed. If the function is called again, local variables are recreated from the scratch. That is why their value is not preserved in between the function calls. Moving on, to look up the variables, we have LEGB rule. L is for local scope. Whenever a variable name is to be looked up, first we have to check in local scope. The language Python interpreter will first look for it in the local scope. If found, then we have to use that occurrence. If it is not found in the local scope, then we check the enclosing scope. If it is not found there, then the Python moves on to global scope and use the global occurrence, if any. If it is not found in global also, then it checks the built-in scope among the built-in keywords or the functions. And if it is not found there also, a name error will be displayed that the variable is not found. Now, what happens when you try to modify global variables inside of functions? Let's have this example wherein you have a global variable x is equal to 100. You define a function and then you try to do x is equal to x plus 10. You try to modify the value of x as x plus 10 and then you call the function. Now what happens in this case is that you get an error, unbound local variable referenced before assignment. Okay, so what happens is that when you try to change this means that you are trying to change the value of a local variable and the local variable x has not yet been defined. Okay, but what you are actually trying to do is you are trying to change the value of the global x. So the correct way to do that is let's have the same code. Before modifying the value, you just have to write the keyword global along with the variable name. So now this line means that this function, my function, will use the global copy of x. Wherever x is referenced to in this function, it means the global x. So now the output will be value of x before calling my function is 100, this line. Then we call my function and it adds 10 to the value. And then value of x after calling my function is 110. The global value is changed because the function is using the global copy of x. That is why the change is made in global variable. So outside the function, x is changed. Moving on, let's have a debug example for the local and global scope. A simple code is there, x and y is equal to 10, 10. We have two variables, both are having value 10. So what happens is that two global variables are created, x with the value 10, y with the value 10. After that we have a function definition. So whenever functions are defined, they are just stored in the memory. They are not called immediately. They are only called when there is a call statement. Okay, so after this line, my function is also stored as a variable, that this is a function at a particular address. Then we call my function with y. Now the value of y is fetched as 10 from the global variables. The value of y is 10, so this y is replaced by 10. Then when we go inside the function, the parameter y will be a local variable and its value is 10. Now these are local variables and these are global variables. Here y is a local variable. Then we write a statement global x. We are using the global copy of x. So x will point to this x in the global space. Then next line is x plus is equal to y. Now here value of y will be taken from the local scope as per LEGB rule. Okay, your y exists in local variables also, global variables also. But as per LEGB rule, we first check for local. So local value is 10, so that value will be used. And x plus is equal to 10 means the value of the global x will be changed to 20 now in here. the value will change to 20. Next line is y star is equal to x. Now in here we don't have a local x, so the global x20 will be used, and y star is equal to 20 means the value of the local y will now change to 200. Okay, now when you access the values of x and y inside my function, x is the global variable, so value will be y, there is a local variable called y, the value is 200. Now once the function call finishes, this local variable will be destroyed. It will get out of scope. Its lifetime will be over. So when we are back to the main code segment, if you try to print the value of x, then that will be taken from the global x20. And the value of y will be taken from the global y, which will be 10, not 200. The 200 value of y got destroyed when the function finished the execution. Okay, so let's test your knowledge, pause the video and try to answer these questions. The next topic is mutable and immutable arguments. In languages like C++, there is a concept of passing the parameters by value or by reference. In the pass by value method, a copy of the variable is created and the changes are not reflected in the original parameters. But in pass by reference, the address of a variable is passed, so the changes made inside the function are reflected back in the original variables. But in Python, the variables are not storage containers, they are memory references. So to illustrate first the pass by value and pass by reference mechanism, let's have this animation. In the pass by value, a parameter is copied. A new copy of the parameter is created in the function inside the function, and if any change is made inside the function, that change is not reflected back in the original variable outside the function. Okay, so you can say that any change made in the parameter does not affect the argument, the original value. But in the pass by reference, a reference to the variable is passed to the function. So both work on the same copy. If inside the function any change is made, then that change is reflected back in the original variable also. Okay, in Python, your immutable arguments behave similarly to pass by value mechanism. Immutable data types are like int, string, float. Okay, so when you pass an integer or a string, then the string, if changed inside the function, will have no effect on the original string because strings are immutable. On the other hand, you have mutable data types. If mutable arguments are passed to the function, they behave similarly to the pass by reference mechanism. For example, list is mutable. So if a list is passed to the function and inside the function any change is made in the list, then that change is reflected in the list outside the function also. So the same reference is passed to the function and both function and the outside code work on the same copy of the list. Let's have some examples. In this first example, we are passing an integer n to the function. Outside the value of n is 100. Then we call the my function, we pass this value to the function n. Now see, this is the global variable and this n will be the local variable. Okay, if you change the local variable n plus is equal to 10, then the local value only will change. The global value will still be 100. So this output reflects the result that value of n inside my function is 110, the changed value, which will be having this id. Id means the address at which the variable is located. But outside, after calling the function, the value of n outside is still 100, the same value. And its id is different from that of the inner n. Let's have another example. When we have a global value, in here, the function is using global n. So id of n inside the function before changing is this. And then we change, then we again print the id. Id means address. The same thing we do in the main segment. Also we print the id, then we call the function, and then we print the id of n, which is the global n, outside n. Okay. So the id of n before calling is, let's say this 712. Inside the function also id is same. But once you change the value n plus is equal to 10, the id changes, because in Python integers are pointers to the memory locations, and already we have a mapping up to 256. So now ID changes, but the ID of global variable global n also changes. Okay, so in this case, when the change is made inside of the function, because the function is accessing a global variable, the value of the global variable is also changed. Now, let's talk about passing strings to functions. Let's have a simple function to count the number of vowels in a string. Define a function, name of the function is count, the parameter is str, which is a string. Then we declare a counter variable, we initiate the value to 0. Then we convert the string to lowercase. Okay, using the library string library function lower. Str is equal to str.lower will convert, will return the lowercase equivalent of str, and the result is stored back into str. So this local variable str is changed, but this will not change the global str, or the parameter that the argument that we will pass. So inside the function, to count the number of vowels, we simply iterate over the string for ch in str. If that ch is in the list of vowels, we increment the counter, then we return the value of the counter. Now, to call this function, let's first have an input string from the user, then we pass that to the function count s. Then again we try to print the original the argument s, the variable s. So the output, as you might have guessed, if we enter the string as education, it counts the number of vowels as 5, but when we print the s, it is still education. It has not been changed to lowercase. Inside the function it will be changed to lowercase, but outside it is still same. Next example, tuples can also be passed to the function in the same way. So in next example, we have how to change strings passed to the functions. Okay, now strings cannot be changed because they are immutable, but you can have the functionality by generating a new string inside the function. Let's call our string str2. We want to jumble a string. Okay, we declare a new string variable and we assign it to empty string. Now we make some changes in str2 based on str1, that if the character is alphabetic, then we replicate it 2 times. Else, if it is not alphabetic, we add a hash sign in place of it, and we add these changes into str2. So str2 will be a new string and we return str2. Then again, same as the previous example, we take an input string from the user, then we write s is equal to jumble of s, because this jumble function will return the changed string and we assign it back to the s variable. So it will jumble the s also, the original s. It will change the value, it will reassign the value. So we are not modifying the string, we are reassigning a new value. So output will be enter any string. Let's say you enter this and this will be changed as this. If it is alphabetic, then the letter will be replicated 2 times. Otherwise, it will be replaced by a hash sign. Moving on, now list and dictionary are mutable, and as we previously discussed, they behave as pass by reference when they are passed to functions. Okay, so if any change is made inside a list inside of a function, then that is made in the original list also. They refer to the same address. Okay, so let's have an example to add 10 to the even values of a list and to subtract 10 from the odd values of a list. Let's say we define a function called modify. My list is the local parameter of the function, local variable. Then we print id of my list wherever it is stored, the reference. Then for every element of the list, one by one, we check if the element is even. If it is even, then we change it by adding 10 into it. Else, if it is odd, we change it by subtracting 10 from it. Outside our function, we declare a list. Then we print the ID of that list outside the function. Then we go ahead and call the modify function by passing this list as an argument. So this list L and this my list parameter, this is argument, this is parameter, both will refer to the same list. The address of both will be same. Then after that, if we print modify list is L, we print the L, then it will have the changes which were done in the function. Okay, so then at last we print the ID of L after modification also. So the output of this function is the ID of L here, this line, ID of L is ending with 760 this. Then we go ahead and call the modify function. It again prints the ID of my list. Now ID of my list also is the same, 760, 760. Both L and my list, they refer to the same memory location. Okay, then what we make some changes. Okay, so as per our changes, 40 has to be changed to 50, 45 has to be changed to 35 because this is odd value. So when we try to print L, then modified L is, it is with the modifications. The L has been changed when printed here. The changes are reflected back in the original list. And ID of L is still the same, address is same. So all the changes are made in place in the same list. The same will be the behavior with the dictionary. Let's say we have a program in which we want to give 10 grace marks to students who scored below 40. We have a dictionary with name of the student and marks. Okay, and we pass that dictionary to a function modify my dictionary. For every k in my dictionary, if the value is less than 40, we add 10, and then you print that the modified d is d. Okay, what happens is that when you get the output of this modified dictionary, it will have the changes. Okay, this 19 will be changed to 29. Okay, so all the changes which are made inside the function will be reflected back in the original dictionary in the main segment. So this is equivalent to pass by reference. So time to test your knowledge. Pause the video, go through these questions, try to answer these questions, and moving on. The next topic is functions using libraries. The library functions. Now library functions are the ones which are defined and stored in modules. They can be called by just using their name and syntax. So in this video we will cover math module. Now this math module is to be imported before using its functionality. Okay, it will have various functions, arithmetic, logarithmic, trigonometric functions. Then we have string functions. String functions are available in Python standard library, so no need to import. Then we have random, again available under random module, which needs to be imported. Then we have statistics, which are available under statistics module, needs to be imported. Now these modules such as this math, random, and statistics, you don't have to download them separately. Whenever you install Python, then automatically by default these modules will be downloaded. They will already be there. They are packaged with the standard Python installation. So no need to download them separately. Once you have a working Python interpreter, you can directly go ahead and import them. So let's talk about different ways to use module functions. So in the first example, to use the functions of a module, we can write import math, then n is equal to math.power. Import math means we import the module math. Then to use the function of the module math, you have to use the name of the module along with the name of the function. Okay. Second example is that you can give an alias, another name, because sometimes the module names will be very long. So to reduce the typing, you can have an alias, short alias, so works the same way. Okay, instead of writing math.power, now you can directly write m.power. Okay, moving on. The other way to import is using from keyword. Okay, from will import selectively. Okay, if you write from math import star, star is a wildcard, which means import everything. So it will import everything in the same namespace. Okay, now to call the function, you need not write math.power, because from math import star means all the functions will be imported directly into your namespace. Okay, and you can import selective ones also. You can write the name of a function which you want to import. You can write from math import power. So now it will only import power function into your code, and you can call that simply by writing n is equal to power 2, 10. Now the benefits of this example are that in this there will be separate namespace. There will be no interference with your own variables or functions. For example, in here you can define your own function called power. Okay, to call your function power, you directly write POW. To call the function power of math library, we can call math.power. So both will be different and both can exist in the same code. Okay, and even if different modules are having same function name, there will be no ambiguity. Okay, and the only drawback is that whole module is imported even if only one function is needed. In this one, the functions or the components are imported into the same namespace. So if you define another function or a variable with the same name, for example, if you define your own power function or power as a variable name, then that will overwrite or that will hide the previous existence of the same name. Okay, so if two modules are having the same function name, then the one which you will import later will have the importance, will have the function working. The other one's function will not be working. And the benefit is that only selected functionality is imported rather than the whole module. Moving on, let's first discuss the math module. Now, along with the function definition, modules have some constants also defined in them. We can use these constants also in the same way that we use functions. So two important constants defined in the math library as per your syllabus are math.py and math.Euler's number, E. Okay, the values are the constant values of pi and the base of natural logarithm. There are some other constants, tau, infinity, and nan. Infinity can be used to compare values with absolute maximum or absolute minimum. Okay. Moving on to the functions of math module. There are various functions. Let's first talk about the arithmetic functions. We have a function factorial. To call the function, you just need to import math and then you can call by math.factorial, then pass the value. So this math.factorial 5 returns 125. In the same way, you can call all the other functions of the math module. Next is ceil n. It will return the smallest integer value greater than or equal to n. Okay, think of this value 4.5. Ceil of 4.5 means the value which is greater than 4.5. The value greater than 4.5 are integer values are 5, 6, 7, 8, 9. And among these greater values, which one is the smallest? Okay, smallest one is 5. So that value will be returned. For the negative numbers, it will be minus 4 because minus 4 will be the smallest value which will be greater than minus 4.5. Okay, minus 4.5, the greater values will be minus 4, minus 3, minus 2, minus 1, greater in the negative timeline. So the smallest among them will be minus 4. Moving on to the next function, we have floor, which returns the largest integer value less than or equal to n. Then we have truncate, which returns the integer part of n. Okay, it will just truncate the decimal part. Okay, 4.5 will just return 4. If you have minus 4.5, it will just return minus 4. It will remove the decimal part. Then we have f mod, which is just to calculate the modulus. Okay, same as your modulus operator. Then we have some power functions, power n comma y. Okay, it means that 2 raised to power 10. Math.power 2 raised to power 10 will return 1024. Then we have exp. Okay, math.exponent of 1 will return e's raised to the power n. N is the parameter that you specify in the function definition. Then you have square root. Square root will return the square root for the positive integers. Next we have logarithmic functions, log 2 of n, then log 10 of n to return the log 2 and log 10 values of n. Then we have some trigonometric functions. We have math.sine, which returns the sine value of angle n, where angle is to be specified in radians. Then similarly we have math.cos, tan, sine, a cos, a tan values. Okay, then we have math.hypotenuse to calculate the hypotenuse of a triangle. Other important functions include math.gcd, which allows you to calculate GCD of two numbers, fsum, to which you can pass a list or a tuple and it will give you sum, arithmetic sum of the elements of the list or tuples, math.radians and math.degrees to convert angle values. Then some new additions in Python 3.8, math.combination and math.permutation to calculate combinations and permutations, math.product, which is similar to fsum. Okay, fsum calculates sum, product will give you product of elements in a list or a tuple. Then I square root, which returns the integer square root of a non-negative integer. Okay, for example, if you pass I square root 65, it will return 8. Okay, not the decimal part, just the integer value. Next we have string functions. Now string functions are called using string object and a dot operator because we don't have to import a module. Okay, they are included in the standard library. They can be invoked by the string object. Let's have some examples. And now first the functions which return true or false, the boolean return values. Is alpha is the function which returns true if all the characters in the string are alphabetic. So in this example, this ABC is the string, and from ABC we are calling is alpha. So this automatically is a parameter for this function. So in this all are alphabetic, so this will return true. So similarly, next function is alnum, which checks for alphanumeric characters. Here hyphen is not alphanumeric, so the function returns false. Similarly, is digit will return true if all are digits. Similar to is digit, we have is decimal and is numeric also. The difference is based on the set of Unicode characters which are recognized as digits. For your syllabus, you just have to use is digit. Then is identifier, which returns true if string is a valid identifier. Okay, in this example, 1 marks the beginning of the name, which cannot be a valid identifier, so this returns false. Next we have is lower, returns true if all are lowercase. Is upper, returns true if all are uppercase. Is space, returns true if all the characters are white spaces, for example space or a tab character. Then we have is title, which returns true if all the words begin with capital letters. Then some more string functions. First one is starts with n. It returns true if the string starts with the specified parameter. Okay, now this is the string which we have to check, ABC space dd dot. Using this we are calling starts with function, and the parameter, additional parameter, is AB. So if this string starts with AB, it will return true. Similarly, we have the next function ends with, which checks if the function string ends with n and will return true. Now this one ends with CDE, not BDE, so it will return false. Lower will convert the string into lowercase and will return the lowercase string. It will not modify the string. Strings are immutable, so it will return a lowercase equivalent. Similarly, upper will return uppercase equivalent. Only the alphabets will be converted into uppercase, remaining are ignored. Then we have capitalize, which will return a capitalized string, just the first letter will be capital. Case fold, it also converts into lowercase. It is just like a strict implementation of lower function. Okay, for example, the German lowercase letter, this one is equivalent to SS, so that will also be converted to SS when you use case fold, and it will not be converted into SS if you use the lower function. Then you have swap case. To change the case, the uppercase will be converted to lowercase and lowercase will be converted into uppercase. Title, to return the title equivalent. For example, this no way out will return the capital first word for all the words, and the string will have capital first word for all the words of the string. Strings are immutable, so no function can change a string. Only modified strings are returned instead. The function join joins all the items in a tuple with the separator specified as the calling string. So if you have t is equal to abc d e f g h I with 3 elements, then this separator dot join t will return abc hyphen def hyphen ghi. Next you have zfill, which will fill the string with zeros on left until its length is n. So this string 50 will be filled with zeros on the left until its length becomes 5 as specified as the parameter. Then we have center n comma x, where a string will be center aligned up to length n using x as the fill character. So if you write abc dot center 15 comma dot, then this string abc will be center aligned by using this dot as the fill character, and the total length will be 15. Similar to this, we have ljust, which will left align a string up to length n using x as the fill character. So this center aligns and ljust will left align. Next we have count, which returns the number of times a value appears in the string. For example, I for I, count I returns 1 because this I with small eye is only appearing once. Encode, it returns the encoded string using the specified encoding encoding scheme. You can specify ASCII also, but by default it is UTF-8. So this string, when encoded, will return this byte string where this symbol will be encoded in UTF-8 format. Next you have find, which will search for the substring X in your string, and you can have optional start and end values if you want to search only in a specific part of the string. So if you have this is it and you don't run find is, then it will return 2 because is starts at 0, 1, 2. So the first occurrence starts at index 2, that is why it will return 2. We'll have examples of the important functions of the strings in the later slides. Index is another function. It is totally similar to find. Find will return -1 if the X is not found, but index will raise an exception when the value is not found. Next we have lstrip, which removes all the leading occurrences of set of characters specified in n, and the default n is space. So if you use lstrip, it removes spaces from the left hand side. If you pass some other string, then all the characters in this string are removed from the left hand side of the passed string. Next we have partition, which splits the string into 3 element tuple. Okay, 3 parts are n will be the middle part, whatever is before n will be the first part, whatever is after n will be the second part. And here is an example to illustrate. Harry loves Sally dot partition loves. Loves becomes the middle element, Harry becomes the first element, and Sally then becomes the second element, third element. Next is replace, which will replace all the old values of the substring with the new substring. Then this is a test dot replace is replaced with capital S. So all the occurrence, first occurrence is this, second occurrence is this, both will be replaced with capital S. Next is split, which splits the string into a list using separator which is passed as the argument as a separator. So if it is, this is a test dot split, by default the separator is space, so it splits the string into list of words. And if it is a colon, then it will split on colon. Okay, whatever value of the separator is specified. Split lines splits the string into a list where each line is a list item. So now let's have an example of the important string functions. Let's define a string s is equal to, this is a test string. First of all, let's call s dot count I. So it will count the number of times I appears in the string, and the result is 3. Next we call s dot count is. The number of times is appears in the list string is 2. Then we have s dot find is. We want to find the starting location, starting index of is, which is 2, because the first occurrence of is starts at index 2. We can look for a string in a substring also by specifying the start and ending point. Here we specify 3, 8, which means that we will start looking for the substring is starting from this 3 index going up to 7. 8 is not included. Okay, going up to 7. So in this part only we will look for is. So it starts from 5, so the result should be 5. Next example, s dot find is 3, 6. So now we are searching from this 3 to 5 in this part only, 3 to 5 part only, because 6 will not be included. So in this part there is no substring is. So if the value is not found, then the find will return -1. Now that return value can be used in if conditions also. Let's say we have s dot find and the return value is stored in the variable called log. So this -1 will be stored in log. Then we can have an if statement that if log is equal to -1, print not found, else print found at index log. Okay, so in this case it will be -1, so the output will be not found. Then there is another function index which behaves exactly in the similar way to find. The only difference is that if it is not found, if the substring is not found, then instead of returning -1, index will raise an exception. It will give you a value error that substring was not found. The next example that we have in here is using the lstrip function. Let's say we have a string s is equal to space, 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 then banana. Then lstrip is a function which will strip the spaces from the left hand side of the string. So the return value is banana. Also, you can strip anything other than space also by specifying that as a parameter, an argument in the lstrip function. So if you have s is equal to this string and you write s dot lstrip, you pass another string. Okay, now this string has dot, comma, and a as its elements. So all these characters on the left hand side will be removed. Okay, dot, comma, a, and a space. Okay, before the first unmatching character. First unmatching character is b. So to the left hand side of this capital B, all occurrences of a, dot, comma, and space will be removed. To the right hand side of this a will not be removed, this a will not be removed. Only on the left hand side of the first non-matching character, all occurrences of this will be removed. So the output of this is banana. Next, let's say we print s. Okay, as we already discussed that these functions will not change the string, so your string will still be this. If you want to make the change in the string, then you have to assign the new value to the string. S is equal to s dot lstrip. Okay, then only the value will be modified. Moving on, let's have another example. Let's say we have a string s dot s is equal to this is a test string. Then you use s dot replace. This is the old value, this is the new value. So you want to replace small cases with the capital S. Okay, so the output will obviously be these two occurrences will be replaced into the capital IS. Let's say you want to replace only the word is, not this part. So in that case, you have to modify your call statement. You can put the old string as space is space, then it will exactly match with the word is. Okay, and you can replace it with space capital is, then again a space. So this time only this is will be replaced because this will not match with the substring. Moving on, let's say you have s dot split on the same string. Your string is, this is a test string, so by default the split variable is, the argument is by default a space, so this will be split on spaces, so all the words will be split into a list. Secondly, let's say you have a string alex colon 27 colon 12 colon 85 and it is a line stored in a file, let's say, which represents name colon age colon class colon marks. You want these individual items. So what you can do is you can write s dot split on colon. You can specify colon as an argument and all the values will be split on colon. The first element will be alex, then colon will be discarded, 27 will become second element, similarly 12 and 85 will become third and fourth element of the list. After string, let's talk about random and statistics modules. We have already covered that in the previous 11th class. First of all, in random module, you have random.random function, which returns a random value from the interval 0, 1. 1 is not included. Then random.randint, which gives you random integer value in the range a and b, a comma b. Both a and b are included. Then you have rand range, which creates first a range. Then from that range, it gives you a random value. Then you have statistics module. Three important functions are mean, which calculates the arithmetic mean of the data. Then mode, which gives you the mode of the data, and median returns the median value of the data. We'll have examples of this random and statistics module. First of all, let's import random because this is the module. So you have to first import the module to use its functionality. Now, if you call r.random, it will give you a random value between 0 and 1. Next function is r.randint. We are passing the parameters as 1, 100. So it will give you a random integer value between 1 and 100. If you run it again, then again you'll have a random value. Third time, let's say you write r.randrange 1, 100, 2. Now here step is 2. So after 1, the next value in the range will be 3, 5, 7, so on. Okay, so your range will create only odd values starting from 1 going up to 99. Okay, stop value is also not included in the range function. So only from these odd values, one random value will be returned. Next we have statistics module. First again you have to import the module. Then let's say we have this list. If you want to calculate mean, just write st.mean, pass the list as the argument. Similarly, st.mode will return the value which has most number of occurrences. Then st.median will give you the median value, the middle value. If the number of values is odd, then directly you'll have a middle value. If the number of values is even, then the average of the two middle values will be returned. Moving on ahead, we have lambda or anonymous function. If you recall, we studied about 4 types of functions. First one was built-in functions, then we had user-defined functions, then we had library functions, and last was lambda or anonymous function. Okay, not so important in terms of your CBSE syllabus, but for an introduction to you, it is an anonymous function, which is a function without a name. So it is created with lambda keyword, and it may be or may not be associated with a variable name. For example, if you write lambda x comma y colon x plus y, what it simply means is that x comma y are parameters and the return value is x plus y. Now this line will do nothing. Okay, it will not show any error also, so Python will tell you that there is nothing wrong in this definition. To use this function, you can pass the parameters in the same line. Okay, lambda, then you pass 2 comma 3, so x will be 2, y will be 3, and the return value will be returned back by the function. Now lambda function can be bound to a variable, so you can bound it to a variable by writing add is equal to lambda x comma y x plus y. Same function is now bound to the variable add. Remember, here add is the variable, but you can call add as a function and it will give you the correct result of a plus b. But if you try to check the name of the function, if you write add, then in the description it will be shown that it is a function lambda, not add. Okay, the name of the function is not add, so that is why we call them anonymous functions, functions without any name. So moving ahead, test your knowledge, go through these questions, pause the video and try to answer all the questions. Okay, so this was your chapter 2 functions in Python, and if you have any doubts, any questions, just write them back to me. I'll get back to you with the answers. Thank you.